Hello student, this is Javed, lecturer Mathematics International Maritime College. Today's video is about real numbers and its properties. First of all, here is a quick recall. Most of the real number we know them, like natural number. Another name of it is counting numbers, because this is natural. In humans we start counting with 1, 2, 3. When the ancient people added 0 in the counting numbers, the new set was called whole numbers. So third, integers. Then at one stage the ancient peoples included negative numbers. 0, 1, 2, 3 were already there. If you see 0, 1, 2, 3 were already there, and they included negative number. I'm writing these 3 points for continuity. They are moving to the right, they are moving to the left, they are moving only to the right. They stop at 1, they stop at 0 on the left. Now further, the integer can be divided into sets. First of all, this set can also be written in short form, like here it is -1 and here it's +1, so we can combine them and write together. Similarly, this +2 and this -2 can be written together. So again it has left side and right side, and there is 0. Just we are shrinking it together, the number. Similarly, +3 is this one, -3 is here, the next will be -4, +4, and so on. Now this set is divided into 4, 5 or more sets. The most important set I'm going to explain here. First of all, positive integers. So positive integers are those integers which start from 1 to the left. These one we call them positive integers. So see, positive integers, they are also actually natural numbers. So this is another name. Positive integers are also natural number. Negative integers start from -1 and then we move to the left. They are negative integers. So you see -1, -2, -3, and it's moving. And note at this point that 0 is neither even nor positive integer. For integer we write actually z. It is neither positive and nor negative. 0 does not fall in positive and negative integer. 0 does not have charge. Okay, the third one is odd integers. Those integers which are not divisible by 2, exact divisibility. We can also write them in short: +1, -1, +3, -3. Even integer, and the important thing is this 0. Okay, so 0 falls in even integer. keep in mind. 0 plus minus 2 plus minus those integers which are divisible by 2. Rational number which can be written in the form of p by q or common fraction of okay, so like 2 by 3 is a rational number. Similarly, 5 is also a rational number because under it we can write 1. So it means from natural number to all this they are rational number. Example of rational. If somebody asks us that give example of a rational number and we give answer is whole number, natural number, positive integer, negative integer, so we are right, we will be right. Okay, rational. All the above sets are rational number. Irrational number are those numbers which cannot be written in the common fraction. For example, square root of 3. Okay, we cannot write this in fraction. We can never write this in fraction, right? Look, we can write one okay, another, so all I will give hint here that all square roots of odd numbers gives us irrational number. This is for some example. Okay, for example, you this time you take 5. Again, it cannot be written in p by q form. If you write like not odd number, prime number, sorry, prime numbers. So if you do 7, so 7 cannot be written. If you take 9, so 9 is odd number but it's prime. It's also not prime, so it can be written, its answer is 3, and 3 is here in the whole number, in the natural number, or in the whole number, in the integers. But if you want to write in the shape, this is a whole number. This is now a fraction. Okay, p by q. You can write in p by q form, not fraction but p by q form you can write. So the square root of all prime numbers are irrational numbers. Okay, and another one example is there, pi. Pi answer also can never be written in this shape. Though we take the pi value some 22 by 7, this is not the exact value of the pi. Keep in mind, this is not the actual value of the pi. This is, we have considered close value to the pi, but it is not exact value. So that is the reason we cannot write pi in this shape. Well, some property I will try to go quickly. You know them. First of all, commutative property. Commutative property means just changing of places. So the answer of 2 plus 5 and 5 plus 2 will be same. Both will give us 7. Another multiplication. So real number are commutative with respect to addition and real number are commutative with respect to multiplication. The order doesn't make changes when we are applying addition and when we are applying subtraction. They are also associative. Associative means if we have three numbers, so choice is ours, if we add 4 and 6 first, or if we add 1 and 4. The answer here is 10 plus 1, and if we add these two, 5 plus 6, both gives us same number, 11. Similarly is the multiplication. So we can say real number are associative with respect to multiplication and addition. Association means kind of grouping. So if we group the first two and if we group the last two in three numbers and apply the addition operation and multiplication operation, there will be no difference. Identities are the numbers which we add with any real numbers and brings us the same value. So look, so 9 plus 0, 3, 0 plus 3, so again we get the same. So 0 is, we call it additive identity. Additive identity. 0 is added with any number, again something, again that number comes out. Similarly, there is another number 1 which is multiplied with another number, some numbers, again the same result. So we call 0 is additive identity and 1 is multiplicative identity. This is additive identity and this is multiplicative identity. By multiplication we get the same number. If we multiply 1 with any number, we get the same result. If 0 is added with any number, we get it. So they are called identities. Inverses. When we add two numbers and the result comes 0, we call them their additive inverses. So 5 plus minus 5 or minus 5 plus 5, they are additive inverses of each other. Similarly, we have multiplicative inverses as well. Look, if we multiply two numbers, 5 multiply 1 by 5, we get 1. Similarly, minus 2 multiply 1 by minus 2 and we get 1. So when you get additive identity and when you get multiplicative identity, we say this is additive inverse and we say multiplicative inverse. Here the result comes multiplicative identity, which is 1, and here it comes 0, which is additive identity, which is 0. So additive identity and multiplicative identity. 5 multiplicative not identity is inverse. 5 multiplicative inverse is 1 by 5, minus 2 multiplicative identity inverse is 1 by minus 2, and additive identity of 5 is minus 5 and that of minus 5 is 5. Distributive property generally applied on three numbers. Here the sign outside the bracket is multiplication, so 5 is multiplied with 3 and 2 and the sign between them is plus. So 5 multiply 2 and then this sign, and 5 is multiplied with 3. From both the sides we get same answer. This property is called distributive property. Look, if you multiply, if simplify it, it comes 5 bracket 5, it comes 10 and this comes 15. So 5 is 25 and 10 plus 5, 15 is 25. So there is a bracket, and inside the bracket the symbol is plus or minus. If it is plus, so we say distributive property of multiplication, distributive property of multiplication outside of the bracket, or if inside it is addition, we say or addition. If inside it is minus, we say it is or minus. There can be three terms inside the brackets, then we say together or addition and subtraction. Let's take another example. Now this time 5 is multiplied from the other side, so side doesn't make problem. Again, it is distributive property. Well, now some other property of real number, that is intersection and union. So union means to combine the elements of two sets. So A and we make one set. So A union B. We combine them and write them in order. So 1, 2. Look, 2 is in both sets. We will write them one time. 3, then 4. 4 is in two sets. We cannot write 4 two times. We cannot write 2 times because it violates the definition of sets. Then it is to be one time. 5. Then 6 is 2 times, so write one time, and 7 and 8. We call it union. In intersection, we just write the common elements. Like here you see 7 is common between A and C, so our only answer is 7. A union B union C. So we combine all of them together. So 1, 2, 3, 4, 5. Take care, don't repeat anything. 6, up, 7, 8, this time 9, and 10 include and set C. So this is A union B union C. All the elements of A, B, C are added up together without any repetition. Intersection in all these three common elements in A, B and C. So what looks common? 7 is here, 7 is not here, 7 is there. So this was the only thing, and here it was 6, but 6 is not there. So there is not a single number, or there are more numbers which lies in all of them. So in this situation, we say that they don't have common elements. 6 is common in B and C. 8 is common in B. 6 is common in A and B, and 8 is common in B and C. So they are common in 2 of the sets. We need something common in all of them. We didn't find anything, so we say they don't have any common element, so the intersection is empty. Now, simplification of real numbers. Okay, we have a 3-term sum. First of all, they are common fraction, and we can simplify common fraction if their LCM is calculated. So 1 can be written by 1, then 5 by 8 and 1 by 6. So first of all we should go for LCM. You would have remembered this from the school time. When we were at school we were doing like this. They are divisible by 1 is come 1 and the remaining 2 are divisible by 2. So 2 4 and 2 3. No more divisibility is possible, so 2, now need to write 1 4 and 3. So it comes out is 3 4 12 24. It means we need to make this one 24, we need to make this 8 24, and we need to make this 6 24. So very easy, one can be made 24 by multiplying it by 24. So something you multiply down, you will multiply in the numerator as well. So 24. 8 can be made 24 by 8. 3s are 24. So don't forget, it will be multiplied there as well. 6 can be made 24 by multiplying it by 4. So by 4. Okay. Now the denominator for all of them is same, so we write one denominator 24. The first number is 24, the another is 15, then minus 4, and now we can easily calculate our answer. 24 plus 15 comes 39. 39 minus 4 is 35 by 24. So now my neat work, but almost similar. 24 by 24, 3 by 3, 4 by 4 are multiplied. Then simplification, 24 in the denominator, same, we write 124, then 39 minus 4, and finally 35 by 24. Another example, this time we have two factors and both the factors have 2 sums. So if the first factor, you see there is 3, so 3 by 1 we can write, plus 1 by 4, another factor we can write 1 by 1 minus 4 by 5. Okay, so this time they are just two fractions. In this case, anyway, LCM is always calculated to be done. So 1 and 4 are not divisible by any number, so its LCM is just 1 and 4 multiplication, it comes out 4. And if you look at 1 and 5, they are not divisible by a single value, single number, so again the LCM is 5. LCM is 5. Okay, so we need to make this 4 and this is already 4. So to make it 4, we multiply this by 4 and this one by 4 as well. Now another LCM is 5, so we need to make it 5, so we multiply this by 5. If we do this by 5, the numerator will also be multiplied with 5. Now the new denominator for first two terms of the factor same, so we write 4 and 12 plus 1, and here 5 minus 4, same denominator, so we write 1, and it will come 13 by 4, another comes 1 by 5, and it comes out to be 13 by 20. Now let's see my clean slide work. So 4 by 4 I explained here, 5 by 5 I explained here. After simplification, both the denominator in the first factors and both the denominator in the second factor became same, so we write them one time and we add the numerators after this multiplication. Now it's up to you if you want to bring this into decimal, so you can do it, otherwise it is done. Thank you, students. I think this will help us in our exercises. Oh, there is another example as well. Let's go for this. Now you can say this is one fraction, one sum, and this is another. So for the first two we do LCM. So for 5 and 2 are not divisible by anything. 5 and 2 are not divisible by anything. So 5, anything means a common number, except one, it comes 10. And for these two, 10 and 15, they are actually divisible by 5. So 5, 2 and 5, 3. So in this case, LCM will be equal to 5, 2 and 3, and it comes out 30. Okay. So in this case, in the first case, 5 can be made 10 if it is multiplied by 2. Look, so multiplied by 2, then we multiply 2 in the numerator as well. 2 can be made 10 if it is multiplied by 5, so 5 will be multiplied in the numerator as well. Now 10 can be made 30 if we multiplied this by 3, so we also multiply 1 by 3. 15 can be made 30 if it is multiplied by 2, similarly 2 will be multiplied in the denominator. So these things are because of that multiplication. Now simplifying these two and these two gives them similarly 9 by 10 and 9 by 30, and this is actually 9 by 10 divided by 9 by 30. At school, teacher used to tell us that whenever you need to finish division, you make it multiplication and take reciprocal or write them upside down, 9 by 3. So it comes this way, then multiply them. So in multiplication, 10 ones are 10 and 10 threes are 30 and 9 with 9. So I hope these sums will help us in our exercises. See you in next video. Thank you.